Hey guys, so this week I'm focusing more on insider insider threats on the cloud in an organization. So normally what would happen is you would have your infrastructure on a normal, on-premise network. I'm saying past 10 years or 10 years prior. But cloud just took it to another level of insane. So here's my formula of insane. Insane is equal to insider threats in brackets into the same current threats. That is your man in the middle, whatever your password leak, whatever it is. Okay. Raised to the power of you not having knowledge of what is happening. So the more knowledge you have, the less it's less than one. So what happens is I know this can be a little insane formula, and this is I just made it up on my own. But as long as it's 0 point something, that means the less knowledge you don't know. Okay, so that 0.2, 0.3 is what knowledge you do not know. If you do not know anything, then you take that as 1 or 2 or 3, and that just raises the power exponentially. So the formula is in brackets inside the threads into the same current threads you have, the whole raised to the power of what knowledge you don't have. So it takes it to another level. This is again my formula and whatever, but yeah, just from an understanding sake. So if you would have to take a normal scenario, what would be the attack process? So first you would have an initial attack, initial access, where the bad actor finds an initial means to get into your assets, your organization, your environment. For an insider, this is he's already inside. So it doesn't really, this step is like it's a cakewalk for a part of it. Like he already is in your network. Depending upon segmentation, all that changes a few parameters, but the first step he's already been past it. He's walked past it. The next step is execution. Now, in a normal case, after the bad actor gets access to the network, he'll execute certain commands. Now, for an insider, now when I say execute certain commands, he basically figures out the lay of the land, understands what he's dealing with. So he's going to execute certain commands. Whereas again, for an insider, he already knows this. He even though he may not be in IT department, if he has knowledge of IT, he will be able to understand what the lay of the land is. So he may not have an exact structure, or he may have an exact structure. So if we go with the worst case scenario, he has an exact structure. He's again got past the second step of getting the lay of the land or executing certain parts of the you know attack. Now, in other cases, he might also execute certain tasks now, or certain jobs or certain commands. Now, if you talk of a developer, again, his job is partially to execute commands, I think. So again, it's hard to put it, or you can't, a security team can't go and tell a developer, okay, you're not allowed to execute commands. It's stupid. So that's again the second problem. And the next case, persistence. So in a normal case, a bad actor would figure out a way to remain persistent on the network. Now, let's take the worst case scenario. The inside actor is a developer. He's on your network. He knows the lay of the land. He knows how things are. It is very easy. I mean, compared to a person who's not in the network at all or a complete outsider, it is very easy for the developer to put a backdoor in it. And even though you might have security protocols, all of that. So there was this one company which I seen where one developer very smartly put a backdoor, but it was in stages. So the backdoor, it was not like he added a piece of code and the backdoor into existence. It was in multiple stages that he added the code. So even when a code review would be done, it would be done of the changes of the code, or the code added or deleted. So if you would see the code added by just what code was added at any given point in time, you wouldn't know that this is a backdoor until unless you've seen the whole code as a whole. Then after that, privilege escalation. Now privilege escalation can be done in ways. So one is from a technical point of view, wherein he, figures out credentials or API keys or whatever, and gains access, gains a higher privilege. And this is what even a normal threat actor would do, or bad actor would do. But now in an organization, a developer could just come and tell the IT, team that, okay, I need full access to a particular account or whatever. It's social engineering. It's like he's walking through, and I'm not trying to stop the developer from doing his job, but this is something that I'm not saying, like, it's weighing it out and being very smart in your approach. Put it in a way that there's minimum damage if something gets leaked. Now something or the other is going to get leaked, something or the other is going to get compromised. All the developer did not have the intention of doing it, but basically he did it by mistake, which I'm going to talk about going ahead. But it does happen by mistake also. The developer releases the keys or whatever publicly on GitHub or whatever, and problems happen. So it's minimizing the damage to the organization. And in the last step, in a normal case, a threat actor would clean up, basically clear all logs and all. Again, certain times it's not worth clearing the logs, because most of that, like, depends on what you are exactly doing or what exactly the threat actor is doing. Some things are logged which makes no use of being logged. So like if you're going to log a default Windows applications that are running, or changes in, I don't know. So it depends on how the network is configured. So sometimes it is worth cleaning up from a attacker's point of view. Sometimes it's just not worth cleaning up. Like, even though you create a huge amount of logs and all, and the organization does not have a person seeing the logs, it's of no use. You can do whatever you want. So that's what I said. It changes from place to place, situation to situation, whatever. Now, what are the kinds of insider threats? I have divided it into four parts. Okay. One is the intentional and in unintentional. Now, in that, you have a destructive and non destructive. So, you can have unintentional and destructive, unintentional and non destructive. The same thing with intentional and destructive, intentional and non destructive. Now, unintentional and destructive is where a developer goes, okay, I'm picking on a developer for a reason, which is that he has access to a lot of technical, um, all the technical stuff. So it is, and we're talking about security, cyber security. So I'm going to be picking on the developer, but it's not compulsory on the developer. And don't go and screw with your developer after this. But yeah. So unintentional and destructive. In this, you have, say, a developer who unintentionally goes and opens all the ports on the firewall because he was testing something out. No offense, nothing, no harm done if it's on your local network, or if it's on a network which only the developer has access to, good. But many times now you would say, or a company would say that, oh yeah, we have a developing network and a production network separate. But in a small to medium sized organization, what would happen? The developer would go and change the code on the system itself. So it may just happen that sometimes he forgets to, he changes the firewall rules and forgets it. Oh, so that is for unintentional and destructive. Now, unintentional and non-destructive. So it could happen that you get a phishing email, or a developer gets a phishing email and he forwards it to his entire team. But you already have a infrastructure in place wherein the end host or the end device cannot go to certain websites, and the website list gets updated every day on a daily basis based on the threats being encountered on the internet, and these lists are publicly available. So yeah, so it doesn't matter if the developer goes to this website or anyone clicks on the link, because they cannot access it. Basically, it's a phishing link or whatever. They cannot access it. There were security measures put in place, so it's non-destructive and unintentional. Okay. Then comes intentional and destructive. This is where a developer would intentionally remove security rules, change a template, OS, change the template for a Docker container, whatever. And know that understand this. It's hard to get the difference between destructive, intentional destructive and unintentional destructive, because both the times the developer is intentionally or unintentionally removing certain policies, changing firewall rule sets, changing the default template of the Docker containers or the OS templates. It's hard to know. So this is where you need to be smart and understand that don't jump on the fact that this is intentionally done. Sometimes it could be unintentionally done, but sometimes it could also be it is intentionally done. So don't, when you're talking to a manager or a C-level exec, don't tell this user is the one who compromised the system, or this user was intentionally trying to change the firewall rules, and put it in this way that this particular user ID was trying to change the rule sets now, and he actually did. Okay, whatever, but this user ID changed the rule. Don't put it on the person, put it on the user or the group or the user on the computer or the client ID, whatever it is, because sometimes you don't know, sometimes it could be the endpoint is compromised. So don't put it directly on the user or the person. And then comes intentionally non-destructive. So again, this is where a malware goes onto a system, and is intentionally put onto a system by a developer, by a IT person, whatever. Okay, but it doesn't matter, because the antivirus just doesn't allow the malware to execute. Say he took the default um, payload from a metasploit and it got flagged by whatever antivirus you're using. He did not encode it that much. So it doesn't matter. It's intentional, but it's non-destructive. Though you do need to catch it again, because you do not know whether it was done on purpose or no. You just know that that particular user ID had started a malware. Could be unintentional also, but it could be intentional also. So now let's come to the rules and privileges. Now any user or service within a cloud can easily be part of an insider scenario, insider threat scenario. Also take into consideration, I said service, because if you're not familiar with how the cloud infrastructure works, you could have an application which is compromised, which is using the API key of your cloud of AWS, Azure, GCP, and the bad actor could be using those keys to execute commands. So it's not necessary a user specifically. So here's an example. This is an unintentional one and more of like used for the wrong purpose, but not in bad faith. So say a developer wants access to certain rights so that he can try out something just for us, testing purposes, whatever. He's trying to execute something, or he's trying to get a particular job done. Okay. But for getting, for putting that into the change, or approving the change, he needs to go through management, he needs to go through IT. It's a long process. He goes and puts in the process request or the change request, but it's taking a time. It's taking some time. But now the application he's developing has an API key. This application, this API key can be used to execute commands and execute the task, because it has full access to the network or the infrastructure. So he doesn't necessarily need to use his own API key, but he uses the application's API key that he is building in order to test and execute the task. Now, from a defender point of view, you will see that that particular service is being used to conduct or do tasks that it's not supposed to. And it's an unintentional process, and this is something that was unintentionally done. Not, I wouldn't say unintentionally done, but it was for the purpose of testing. So again, you have a problem where something is being used for something that it's not supposed to be, and eventually that API key can get compromised or whatever, and you have a problem to deal with. So what is the solution to all of these things? Stop thinking that the cloud environment is an outside source, like a trusted source. Anything and everything on the cloud, view it as a potentially untrusted environment, the whole cloud infrastructure. Now, you have to do it in a way that it doesn't hamper or restrict the business process. Okay, but you need to do it smartly. You can't, go and say, okay, the cloud is an untrusted network, so you're not going to use it. We are eventually going to go to the cloud, so you can't fight it. And there are pros and cons to it. In fact, I'd say many things on the cloud are much more better than what it is on on-premise infrastructure. So use it to your advantage. The next thing, understand your application behavior, what your application is doing from a network point of view, from a resource point of view, from a CPU or RAM point of view, whatever. Understand the application. Understand, and this also goes to users. Understand the user. Your user should, like a marketing department, should not be able to access your, should not be able to create servers. I mean, this is an example, but they shouldn't be able to create servers. If they're creating servers, you have a problem. That means something is compromised, or so there's some kind of a problem. And even though if they don't have the ability to create an instance or a server, the very fact that they try to do it could mean that their password is compromised. Now it could be like a guy just screwing around, or he just wants to see what he could do on AWS or Azure or whatever. But just saying, it could be a false positive, but it could not be a false positive also. It could be a true positive. So understand both the sides and understand your user, understand your application. So as a security team, once you identify what you're looking for, you can easily create automated tools in Python or whatever, or using the CLI of, no, I know AWS. I'm not that familiar with Azure and GCP or any of the other cloud providers. So I'll try and keep this as cloud neutral as possible, so you could implement this in any cloud infrastructure or environment. But understand the main key concepts. Once you understand the main key concepts, you can implement it however you want, wherever you want, as long as whatever your base is true. Okay, now once you understand the behavior of a particular user or service, you can create the tools or rule set that it's supposed to follow or it's not supposed to follow. So if it's not supposed to be doing certain things, put an alert, put a raise a ticket, whatever it is. Put an email, shoot an email to the head of the CISO, or not say CISO, to an analyst, or depending on the threat model and or how big it is, whatever. But have something that it logs a ticket so that someone can actually go and see it. And when I see it, it does not mean it goes and a person sees it after a week or after a month, because by that time the attacker would have compromised majority of the system. So see it as soon as possible. So maybe within 24 hours, 48 hours, or that very instance is possible. So what kind of detect key points do you log when a person launches a workload from an unapproved template, launching a container from an unapproved image in a repository? Okay, so basically, if you have a secure container template and a developer goes and launches it in a trusted network, then you have a problem. Put it as an alert. When you have some when you have a developer or any kind of service or application or user deploying assets which are unapproved in regions which are unapproved. So it could be that a developer is just so that it doesn't show on your main dashboard that any resources are there in US West region. Just saying. Now this is for AWS. So if you log into your AWS console, you are mainly seeing that particular region. A region is basically a location on Earth. So US West is a particular region. Okay, now any servers in that region, you will see it in the dashboard. If you want to see the whole thing, you need to go to globally, or you need to go to that particular region. But by default, it's set to US East, if I'm not wrong, East one or US West one, I forgot. But what a person would do is go and deploy a resource in another region, say like India, UK, European region, whatever it is. So it wouldn't show by default in your dashboard. You need to either search through it, or you'll have to go through the billing and see where all services are, servers are, whatever. Then when a user or service enables or disables any IAM policy or rules, then when you're disabling any logging system security controls, again you put an alert. When you're logging in through the web console, whether it is authorized or unauthorized. Okay, now, okay, I'll cut this point out. So anything, next one, behaving anomalously. So anything which is not supposed to, you know, hiding tracks, whatever, there are ways to do it. It depends on what is the infrastructure. So yeah, and I think this might be a little hard to put it in a rule set. This is something where an analyst might need to see it, but yeah. Then adding new workloads to image, adding new containers, updating new containers which are not approved to the approved containers, changing of serverless configuration, changing of all the codes in the serverless configuration, changing of adding of new serverless configs or codes which are in a trusted network, changing security groups, changing network ACLs. So these are again a few things, but it's just a guideline to help you. So what all do you log? API requests made to the cloud, requests made through the browser, and tracking assets and behavioral analytics based on the logs. So tracking assets could include human assets and assets on the cloud. Human assets. Now I consider humans as also an asset. Now an asset should behave the way it's supposed to behave. Anything out of it, flag it. So if a person is in US and suddenly he's logging from another country, you have a problem. If a server is supposed to be in US and it is logging in from another country, you again have a problem. That means that API key has been compromised. So be smart in it and correlate accounts based on the use of the accounts. So again, coming back to my previous example, marketing doesn't need to create new servers normally. So if that is the case that they're creating new servers, then you have a problem. So here's an incident that did happen. So I was hired by a company to perform, check their infrastructure, all of that. And it was a pretty good company. I mean, they're full cloud native. It was a startup and very progressive in nature. Like, they were forward thinking. I would say that. So they got me on board, and their architecture was pretty good. They added a few changes, but good enough for a company, who started from scratch. Yeah, good enough. Now, when I did a scan of their network, there were certain servers that weren't there on the architecture of what I seen on paper. When I went and checked why those servers were there on that particular network, or I would say were there on that trusted network, I realized that a developer created a server for testing purposes, which was unauthorized in the sense, it was authorized like he could test it out, but he didn't test it out on his own personal account. He tested it on the cloud, on the infrastructure of the cloud of the company, which was on a trusted network. That server was vulnerable. He was using an old server image, and he had to do it on an old server image for certain reasons, which I understand. But yeah, The problem was that one triple server had access to the network or the internet and was on a trusted network. That is where problems started. So no problem really started, but a problem, it was like a bomb waiting to explode. So keep monitoring your assets that are deployed and in your cloud environment and understand the nature of it. Then you can make your network more secure.